with clean residue that we can recycle.
DP Patterning is a company based in Norrköping. It's research-based, and the uniqueness of the company is that we have developed a technology that can produce flexible circuit boards without using any chemicals. I developed the technology in 2001 when I was working at a research institute called RISE. I saw the need of producing electronics in a more environmental and sustainable way. If you have any kind of electronics in your product today, you for sure have a circuit board there, and probably you buy it from a sub-supplier. But by introducing our green production technology, you compress the supply chain and cut out one sub-supplier and have better control over quality, cost and lead times. The core business of our company is to sell machines. Actually, we have a pilot line here in the office.
So the main thing that differs this production technique from conventional is that we don't use any chemicals. We're only using a mechanical removing process. And that also ends up with clean residue that we can recycle for a more environmentally friendly process. The big advantages with this machine is that you can have your own in-house production. That means that you can go from prototype to finished product very quickly. On top of that, you will have your own quality control where you control both the product quality, but you will also keep the intellectual property rights in your house. This is the actual cutting unit. This is where we do the processing of the material. So we put it on the magnetic cylinder and then we can process any pattern we would like. We are able to process products in a high speed, but also do tool changes, change patterns very quickly. So compared to conventional etching technology, we're able to process material up to 10 times faster through this machine, which will give you, as a customer, more output per hour. You do all the production in your facility. We support you with all the information and all the knowledge you will need to set up this machine to make it work as you wish. And my hopes for the future is that we can continue to develop and refine this process to become even better.
What we want to do is to revolutionize the world by turning the way you produce flexible circuit board upside down. We see a huge demand for this technology, and together with our customers' R&D departments, we develop the technology further and we are expanding worldwide now. I think it's all our responsibility to have sustainability in the top of our head. We have one globe to take care of, and I would like my kids to enjoy the nature as much as I do in the future. Good afternoon, everyone, and welcome to this DPP live webinar. Today we will look into some technical details, and I hope you enjoyed the video. Meanwhile, we're waiting for some attendees to connect to the webinar. My name is Staffan Nordinder, and I'm the CEO of DP Patterning. And together with my colleagues today, Joachim and Andrei, we will guide you through how to convert your design ideas to a real functional FPCB, flexible printed circuit boards, within less than 45 minutes. The first of all, some practical information. You can see chat in the webinar. You can type in the questions you can come up with during the webinar, and we try to answer them in the end of the webinar. There is also always a possibility to contact us at info@dppatterning.com, of course. DP Patterning is a tech-based company that produces machineries. And the unique thing with the machine is that we can process printed circuit boards without using any chemicals. This revolutionizing idea was developed at the Swedish Research Institute, RISE. And one of the unique things with the process is, as I said, you can, by not using any chemicals, you can bring this production method in-house to your own facility. And this gives you full control over delivery times and shipment, of course, and the quality of the produced parts. And that is, of course, very interesting in these times of Corona, Swiss channels, and silicon shortage. The schedule today will be that we have a short introduction that we did right now, and then we have a walkthrough of the DPP 360 machine. That is our production machine, and then we stop by the design table, and then we produce the tool that we need for patterning the PCBs, and then we quickly set up the machine, and then we go to production. By in-house, we mean really in-house. So we took this one step further in the office here. So we have it in-office machine production. So next to me, we have our office and also machines. So now we would like to invite you to our machine room, close to the office. So now we walk in to see, as you see, it's a completely normal office place, meaning that the working environment is completely safe and it will not generate a lot of dust. Some of our customers actually have this machine sitting next to a pick-and-place machine for bed attachment. So it's very clean in both many ways. And when you run the machine, normally you see it closed like this. And inside this cabinet, you will find the production parts. See if we can open it nicely like this. And if you come over here and look into the first section of the machine, here you see the raw material supply, and this is exactly the same raw material that all FPCB suppliers use. You can have different metals and different plastic laminates. The metal we use could be either aluminum that we have today, or it could be copper or combination of copper and aluminum in what we call copper-cladded aluminum. The carrier could be PT, PI, PEN, variety of plastic materials possible to use, and you can combine them in many different ways. And actually, here is where the magic happens. This is the processing module, where we have the processing nip, where the material will be fed through later on. And in between the mechanical cutter and the tool holder, everything is done in one single step. In difference with traditional etching technology, where you first print your ester resist in one machine, and then you move it to another machine, and then you put it in an etching liquid, and after that you have to clean it, of course. And when you etch, you will have a residue in a liquid form. In our machine, we have a residue in a dry powder form, and this is 100% recyclable. And actually, we get paid for the residues in our machine, and the etching company has to pay for their waste. And later on in the machine, we have what we call an expansion unit. And here is where you can place whatever additional equipment you like. For instance, you could place electrical measurements, marking, post-processing equipment. Maybe you would like to have a corona because you would like to laminate the material later on. And that could be installed in this area. Now we have it in our lab machine here. We only have the inkjet marker, so we can identify each single product. And together with this section here, where we have the camera, this is a 100% web inspection camera, high resolution, and you can use it to do a variety of things. In this case, today we will only measure the product dimensions and to have full control over the size of the product that we will produce. But you can also teach the camera to detect deviations in the production. And together with a marker system like we have here in inkjet, you can have full traceability of each single produced part. And all the data from the camera and the inkjet marker can go into a database, so you can later on combine the data and follow up your production. And the final step, super easy. You just wind up the produced parts onto a supply roll, and then when production is done, you just stop the machine and cut it out. And now we go over to the design table here, and it's also next to the machine. So you see here is Joachim sitting next to his office table.
Hello there, Stefan.
Hi, Joachim. Nice to see you again. Joachim, tell us a little bit what happens as a first step after our customer send a design file.
Yeah, so like to say, the customer sends us the design file. It can be a step file or a PDF or
Gerber file.
Gerber, something that is completely finished or something that needs a bit of touch up. But usually, when we get the design file, it's 5 to 10 minutes until we can send it off for usually mass manufacturing, which you will take a look at later on in the cliché machine.
Mm.
But potentially, you could also use the same design file for lasering one of these tools, the clichés.
Is this something that you, as a user of the machine, can do on your own?
Yes, definitely. Yeah. In-house. That would be the preferred solution.
Yeah. So this setup we're showing here today is very much like how it could look like at the production facility.
Yes.
Good. So what's the next step? When you produce the, I see that you used a graphical program here, used in the graphical industry. And why is you using this type of tools instead of electrical CAD tool?
Yeah, well, this is a legacy from the printing industry. It's they use vectorized formats and applications. So that's what we adapt to, and that's the extra step needed to go from Gerber or step files to the printing industry.
To the next step. So,
yes.
And what is the next step then?
The next step is to feed the mask into the cliché machine.
Okay. So, and we now switch over to Andre in the cliché manufacturing room. And I will have a short walk there. So now I'm very soon close to Andre here, and he is picking up a cliché from a mask, sorry, from the printer, and this mask could be either inkjet printed or in this case is laser printed. But it's just a plain transparent PET foil with this black pattern on. And you see the green part here at Andre applied to the table is a photosensitive polymer. And by having light exposing some parts of the polymer, those parts will be hard. And in the next step in the machine where we put the cliché material to water exposure, we will actually wash off the uncured or unexposed parts. But as you see, it's very smooth and convenient way to just apply the mask into the photopolymer. And now we showed a way to use a cliché material, mask to produce the cliché material. And the benefit of using a mask is that you can reuse it many times, and the manufacturing process is extremely fast. So now we only expose it like 60 seconds, and then we put it in the washing machine and develop the actual pattern. Our process, like all printing processes, actually needs topography to work. So how long is it? The machine stops itself after exposure?
10 seconds.
Okay, good. So not you miss the next step from Andre. But as I said, we need some kind of topography, like a flexo printing plate. And now the actual exposure of the tool is done, and then we just put it in the washing equipment. Simple as that. Sits with a magnet, and then we just start the washing. And this is just brushes and water. Of course, very delicate tune, so they will be touching the surface very gently. There are other ways to produce the tool in our machine. If you not like to use this, what we call a photolithography system. This is a low-cost investment system produced by a sub-supplier to us. But you can also use something called computer-to-plate technology, where you, instead of having a separate mask, you just place the photopolymer with a carbon material on top, and then the laser can define the pattern itself. And then you put it in the same type of developing or washing equipment like this. And the drawback with this method is that it's a little bit more costly, but it also takes some time for you to print the whole surface of the mask. And of course, it's also, you need to do the same operation over and over again for each single cliché you would like to manufacture. There's a third way that we use as well, and it's called direct laser engraving, DLE. And this means that we have the same type of material, but fully hardened all through the bulk. And then we have a laser that actually engrave the surface to create this topography. This is a super smooth operation, of course, since you can take directly from the computer to this system. In one single step, you have the tool ready. There are few more steps here, but it's a very convenient way to work like this. And of course, these direct laser engraver are a little bit more costly as an investment. And now you see, after this 2 minutes, the tool is ready for production almost. Now it's been soaked into water, so the only thing we have to do now is to dry it off. So Andre is just removing the excess water, and then we will put it in the oven to dry for 10 minutes. Just release it from the, and I can see if I can show you how the pattern looks like now. So let's see if you can, and you see there is a topography of this surface now. And in this case, the height of the cliché here is only 200 micron. And this is very common material in the printing industry, so it's easy to access and to produce. And to save us the 10 minutes, we have make like all TV chefs prepared a cliché for us, and I guess it's ready. Yes. So we cut the production sorry with 10 minutes, but now I bring the same cliché you saw right 10 seconds ago and bring it to the machine room. So over to the machine room. So, soon by Joachim, and just have to take my cliché with me. And here's Joachim waiting for us.
Hey, Fluff.
Hello again. I put it here?
Yeah,
Another upside down?
Upside down. That's
Thank
fine.
you.
So, are we ready to mount the tool?
Yes, the tool is cured and hardened, and we also touched it up with some paint on the top, and you will explain later on why.
Yes, sure.
Could you show us a little bit walkthrough of the HMI?
Yes. So this is the screen HMI, then showing the heart of the machine. And on the first window, you can see that you have a login window with different profiles or possibly users. I'm going to log in with Process Engineer because then I can do all the steps from making a recipe, loading the recipe, and running the machine. So I'm going to log in. And the first step, there are a few tabs to look at, but the first step will be to load the recipe that we want to load. And for that, we need to be in production mode.
And what's the difference between production mode and you are in cliché change mode?
Yeah, exactly. So there are different modes depending on the safety level needed from the operator point of view. So in production or manual mode, there's the most amount of security, user security. Yeah,
you just have to
doing it live. There is some good explanation for this, but anyway, so this is the recipe. You load the recipe, you choose a recipe. Usually someone has already made the recipe for you and you just load it. In here, you can input things like the web speed, the cutter speed of the tool, things like recipe information for the vision, which we will look at and talk a bit more about in a bit. And you can also, over here, load things like material information, roll batch number, material type, order type, etc., which is then logged to a database. So when you've done this, you're ready to load the cliché Staffan just brought me. So we will switch back. Did I miss something, Staffan? Do you have anything?
No. And worth mentioning is that you can connect this to an MES system, so you can download recipe from your superior system. So, and this is all decided by the operator level access. For instance, maybe one operator is not allowed to change anything in the setup, and it's only downloaded from the MES system. And this is, of course, bidirectional. So all data we generate in the machine is uploaded as well. Now, Joachim would like to show something.
So now I've loaded the tool, the cliché, entered it into the groove. So it's perfectly parallel with the magnetic cylinder direction. So now Staffan will help me press the button. This is perfectly doable by a single operator without any issues. And that's how I usually operate the machine and how we train other operators to use the machine.
Well, we don't have the camera guy in the middle.
Exactly.
So now smoothly wind it up to the magnetic cylinder. And we call it magnetic cylinder because it's actually a magnet that keeps the tool onto the cylinder surface. So this makes it very easy to change tool. We just remove it. There is no clamps screwing anything. You just rip it off, gently, of course, and then you can change to a new tool.
Okay, so now the tool is in, and I'm just going to restore the web. Before...
Right. Trim the cliché first.
Ah, yes. It's better to do it in that order.
Yeah.
So first we trim the cliché, and that means, stuff I mentioned before, we had this black mask cover on, and that was applied so we could see when we trim the cliché that we're actually making it perfectly rounded and adapted to the magnetic cylinder. And this is what helps us achieve micrometer level milling on the material later.
So meanwhile, Joachim starts here. When you see the top surfaces that are black turns into green, you know that the full cliché has been retrimmed.
Yep.
Good. So shoot.
Yeah. So we're ready to go. So I'm just gonna go.
And we use the same tool now to trim the tool itself. And the tool itself, since in this case the aluminum material we will remove is only 9 microns thick, the accuracy of the runout of the cylinder is very important. And also this could be smaller variations in the runout thickness of the photopolymer or things like that. And this will be all compensated away by doing this operation. And it only takes us a few minutes to do this. And now we can see that we slowly are closing into the right depth. It becomes greener and greener.
And of course, this is covered by the operator training, how to do it, and how to succeed every time. It's a very simple process for a trained operator.
And other things worth mentioning is that each single touch of a button or the HMI is recorded or stored in a database, so we can find root causes to deviations in production to help the operator and maintenance personnel to track down what actually has happened. If it was an operator mistake or if it was something that needed to be adjusted even more. And now the cliche is trimmed.
Yes.
And now you go to what do you do now?
Okay, now I'm just, since we trimmed the cliche, we were actually milling into the cliche. Now I go out and leave some space for the material to go in. So now we're basically ready for the material.
Whoa.
Yeah, we're just gonna let it take some time.
No problem. Now Joachim just ensures that we are in the right position.
Okay,
And it seems
sure.
Good.
So now we're ready to mount the material again. So there are several different variations on how you can optimize your mounting or changeover of the machine. And this is one of the fastest ones when you have it already pre-mounted and you're just switching the tool. And as you can see, the switching of the tool is between 5 to 10 minutes if you have optimized all the other tasks that needs to be done. So what I'm doing now is just reattaching the material to itself. Using some ordinary tape. And then we're ready to feed it forward and get the machine ready to go. Okay.
And now Joachim has to change to production mode again. And today we have removed all the safety features to be able for you to be able to see the machine running in with the doors open. Normally, this next step will always be performed with the doors closed.
Yeah. So now I'm tensioning up the web according to the recipe we had before, and what happens here then is if we look at the HMI screen, which is a great help for the operator, you can see that the bars goes green. In this case over here, it's still red because it's a special case for we don't use the printer today. But it highlights that, well, the printer will not work if we start now. That's fine. So now we're ready to go. Are you ready, Staffan?
Yeah, I'm ready.
Yeah, let's go. So we start at 10 meters a minute. We're just gonna roll through a few meters so we get past the critical point of the nipper, grabbing the material. Yep. So we are ready to go, and I'm gonna go.
So now you engage the cutter.
Yes.
And as you see, the first single products coming out from the machine is fully functional. Now we are running in 10 meters per minute.
Yep. We can crank it up to 20 meters.
Yeah. And maybe you can show us the vision system as well as it looks
Yeah,
like.
sure. So we have an inline vision system that enables us to do a full inline scan and analysis of the product. So this is fully customer.
It looks like the same picture, but it's just similar.
Yes. And this is a 40 micrometer pixel resolution, so it's definitely a very high performing line camera we're using, but this can be customized to your need as necessary.
Is there anything else you need to do now when you started the production, or can you just leave it running like this?
Now it's going. And we have built-in safety measures that monitors the machine to make sure it doesn't go out of process without alerting the operator. Yeah.
Yeah. Should we stop and or
Yeah, we can stop the
see
machine
how it looks like?
and take
over
out
here?
some parts.
Yeah.
So I'm just gonna stop it.
Yes.
Okay.
Thank you for that.
Right away, we are ready to take out either a whole roll of samples or just a small sample sheet.
Yeah.
So
And is it okay for me to release the
Yeah.
potential?
go ahead.
So you can see you can either operate the machine on the machine itself with some buttons on the positions where it's common that operator do tasks, or from the HMI. So now you see we produce some meters here, and normally the machine stops itself after the work order is fulfilled. And out of the machine you will have the fully functional, nice heaters in this case. I didn't talk about it before, but the aluminum circuit board is a really growing market today. We see it both in heaters and RFID systems, but also in more and more in the interconnection because of the lower environmental footprint, but also the lower cost, of course. So maybe we should finalize this, round it up in the coffee area again.
Yeah.
So over to the stage again. I bring the roll. So one great thing with the machine is, since you change over so fast, you can use this machine for either prototyping. Maybe that's what we made today. Just run, I don't know, 50 meters, but you can also run 1 meter. Or you can just leave the machine running for hours and hours and produce thousands of meters. So you see here, we produce a substantial amount of material in a really short time. And this is one of the beauties with the machine we have. And I guess we are well under the 45 minutes we promised, even that we cheated with the 10 minutes of drying of the cliche. I promise we can make it with drying as well. Not so funny to watch ink drying though. And I said we are a machine manufacturing company, and we don't just sell machine off the shelves. We always work very close together with our customer and really needs to understand the problem and the challenges each customer have. And by doing this, we do this by going into the depth on the products the customer have. And with our knowledge from research field, we are very well equipped within the company to help customers with both design and machine related topics and configurations. And we would like to find the right solution for your products exactly. And this is ensuring us that you will have an effortless ownership of the machinery and production. Because we like to not travel so much. We really like to be in Norrköping. It's a nice city. And we doing this by training the operator and the maintenance personnel on site to the level that you can do almost everything on your own. That's our core interest, to train the customer to do everything on their own. Of course, we are, as a backup in the background, can always assist you remote or on site. And since we have the research background, we have designed the machine, we have built the machine, we have, of course, a great knowledge of what we're talking about. And we can help you out with all these topics, everyday topics from operation and more. So I think we might have time for some questions. I don't know what the time is. We have a few minutes more. So Joachim, can you see if there is any questions in the chat?
Yeah, sure. There are a few questions. We have one here about how many machines do we currently have on the market?
We have several machines on the market today, and exact number it's between us and the customer. But we are having machines in Asia and in Europe.
Yeah, great. And they are in serial production then?
Yes, serial production machines. So it's not just a prototype, as I said. This is a serial production machine that can be used for prototyping.
Great. We have a few more questions. For example, what's the minimum pitch that can be produced on a typical material?
The pitch we produce is depending on the material we use. But for instance, when we produce RFID antennas in the machine, we do gap sizes down to 100 micron on 9 micrometer aluminum. And on this gap, customers attach a bare die component. So it's very tight resolution and it needs to be a very clean process.
What was the pitch on this heater with
today we had 1 millimeter lines, I think. So the pitch was 1500 micron. But also we have customers that are producing lines down to 300 micron, and we can make landing areas for QFN ships with a pitch of 500 micron.
Yeah, sure. We have one more question here from the audience. Is there a possibility to make via holes with the DPP process?
Yes, to some extent there is. And then we normally have to run it twice or use 2 cutting systems next to each other. I didn't say that before, but the machine is very modular built, so you can attach as many cutting units you like, more or less. We like to sell many, so please buy many of them. But also we can attach or remove expansion units. The expansion unit is not needed for process itself.
Okay, thank you. And there's another question, and that is, what is the maximum speed the process can be running at the moment?
Today we run 20 meters per minute. The speed is not process related. It's more related to the machine safety. So we need to, the machine is designed to stop in a certain amount of time. So when you're running 20 meters per minute and you open the doors, the machine should stop before it becomes you can touch any critical moving parts.
Okay. So the next one, what is the size of the printable area in the machine?
The standard print area is, we divided in two questions. The length is between 400 and 800 millimeters printing length in the standard version. We can extend the machine up to 1200 millimeter. And the width is, standard width is 360 millimeters in this machine, but can also be extended to 410 millimeters, I think. Is that right? I'm looking at David here. Yeah, 410.
Okay, thank you. So what is the maximal thickness of the metal? Can you remove plastic from metal instead of metal from the plastic?
Oh.
So it's basically the VIA question.
Yeah, double question. Yeah, okay. So, but maybe it's not exactly the VIA question. You can remove plastic from the material. For instance, we have customers that would like to not make an electrical pattern, but they will just like to remove plastic from another layer. Right. And since this is not a chem etch process, we can mill down into the plastic layer, or we can have multi layers of plastic, metal, plastic, and drill all the way through. What we are limited in the stiffness, total stiffness of the laminate. The thicker the laminate, the worse resolution.
So what did you mention about the thickness of the metal?
Of the metal, oh, sorry. The thickness of the metal, we run today up to 35 micron copper on specific materials, and the same range of the aluminum.
And 35 micron copper is one ounce copper, if I remember correctly. Yeah. Good. We have one more here, and it's kind of related. Can you cut through multi-metal stacks?
Yes, this is exactly what we do. I think I mentioned the CCA, the copper-cladded aluminum. In that case, we have, together with a supplier, developed the material for this process, where we have any plastic carrier we would like, and then we apply an aluminum layer, and then on top of that, a very thin copper layer. This makes the material look like aluminum from an electrical point of view, and it looks like copper from a soldering point of view. So you can have the low price of the aluminum, the environmental friendliness of the aluminum, but the solderability of copper. Yeah, so it's, and of course you can have any variation of metal in any order.
Yeah.
Good.
Okay, great. I think it looks like we are out of questions here. So you could wrap things up here, Stefan.
Thank you, Joachim. It's been a pleasure to doing this first webinar, first tech webinar from DP Patterning. Challenging and a lot of efforts made by Joachim and our colleagues. We thank you for that, and especially we thank you all the audience looking into this webinar. It will be available on the net. We send out the link to you, and we would love to hear from you again and to discuss your problems and how we can solve them for you. Thank you very much from DPP today in Norrköping. Bye-bye.